Hi everyone, welcome back to PraveenTechlab. In this video, we are going to build and demo a smart student assistant using multi-server MCP architecture with streamable HTTP and OpenAI reasoning. The UI now has three MCP servers: calendar server, notes server, quiz server. Now I'm typing a query, help me prepare for my exam tomorrow. When we post this query, the agent asks OpenAI what student wants. Based on that intent, it calls only the required MCP servers. For this query, it checks the calendar server, reads AI notes, generates quiz questions, and asks OpenAI to create the study plan and final response. This is the complete flow. Now let us understand how it works. Roadmap, what we are going to cover today. First, we'll look into the architecture diagram. Before writing single line of code, we'll look at the full system diagram. What components exist, how they connect, and which layer is responsible for what. This gives you mental model for everything that follows. Second, code walkthrough. We go through all four files one by one. Calendar server.py, notes server.py, quiz server.py, and agent client.py. Each file is small and focused, so it's easy to understand exactly what it does and why it separates. Next, setup and config. We set up the virtual environment, install dependencies, and configure the .env file with the OpenAI key and model name. Next, in live demo, we run the full agent both from the command line and using the Tkinter desktop UI. You will see the agent call the three MCP servers in sequence and watch OpenAI compose the final study plan in real time. Next, architecture diagram. User layer. At the top is the student's question. Help me prepare for my AI exam tomorrow. This enters through the Tkinter UI. The green final answer box on the right is what comes back. A structured study plan with exam details, topics, and practice quiz. Agent layer. Agent underscore client.py is the coordinator. It does not contain any student data or any business logic. Its only job is to call the right tools in the right order and pass the results to OpenAI. It holds three simultaneous MCP connections using AsyncExitStack. Next, LLM layer. OpenAI called twice, one at the start to understand the intent, one at the end to compose the final answer, using everything the MCP servers returned. MCP layer. Three independent servers running on its own port. The agent calls each one server over a streamable HTTP using call underscore tool. Each server owns exactly one responsibility: calendar data, note reading, quiz generation. None of them knows the other exists. Next, data layer. At the bottom is the actual data each server reads. The academic calendar events, the markdown files in the notes folder, and quiz templates. Now look into the real-time code flow. When a student asks, help me prepare for my AI exam tomorrow, OpenAI returns an intent plan. This is a JSON structure. Intent column full preparation needs calendar true or false, needs notes true or false, needs plan true or false, needs quiz true or false. Then the agent follows the plan, calls the calendar server to find the exam, calls the note server to find and read AI notes, keeps study plan generation for OpenAI reasoning, calls quiz server to create practice questions, asks OpenAI to create the study plan and final response. Now look into the code block. First is calendar server. This code block creates and configures an MCP server named student underscore calendar underscore server run locally on 127.0.01 and port 8101 with streaming HTTP endpoint at /MCP. These servers connects to the student's academic schedule and returns upcoming exams and events for the next few days. The agent calls this first to find out what exam is coming and when. So OpenAI can build time-aware study plan. The server exposes get upcoming events tool. This is the main tool exposed by calendar server. It lets the agent ask the calendar MCP server for upcoming student events. Here we are creating the demo events. This helper underscore event builds events related to the current date. Date offset 0 means today. 1 means tomorrow. 2 means 2 days from today. Next, this line calculates the final date to include in the search window. Next, filtering the events. Filtering the events only between today and the cutoff date are returned. Finally, we are constructing the JSON response. The JSON result gives the agent a structured calendar context. OpenAI can then use this context to create the study plan and final answer. Next is notes server. Reads real markdown files from the local notes folder and returns their titles and full content to the agent. The agent uses this content to extract study topics, which then feed into both the OpenAI study plan and the quiz server. We are creating the note server with name student underscore notes underscore server on port 8102 with streaming HTTP endpoint at /MCP. This server exposes two tools. One is list notes. Second one is read notes. List note. It looks inside the notes folder, shows all notes. If you give a search query, it finds only notes that match that word. It checks both the file name and content. For each note, it takes the title from the first line. Final purpose of this tool is helps the agent to find which notes are useful first. Next, read note. Opens one note file and reads everything inside. Before opening, it checks the file is safe or not. Finally, returns the full content of that note. Next is quiz server. This code block configures quiz server with name student underscore quiz server to run locally on 127.0.1 on port 8103 with streaming HTTP endpoint at /MCP. This server exposes two tools. One is generate quiz, another is the get revision tip tool. The generate quiz tool takes a list of topics and create the short questions with revision tips for each. Next, get revision tool gives a quick study tip for a single topic. This only works with the topics provided by the agent and returns results in the JSON format. Now we look into the agent code. When the user clicks run underscore demo on the UI, it calls the start underscore demo function. This function starts background worker thread. Why? Because UI stays responsive and doesn't freeze while the agent is running. Inside this worker thread, we are calling the run underscore demo. Now the actual agent flow starts inside this run underscore demo function. Here we are calling the OpenAI LLM to understand the user's query intent and create the intent plan. First, we are initializing OpenAI SDK. Next, selecting the OpenAI model, and then we are defining the system prompt. Using this system prompt, we are telling the LLM roles, constraints, available tools, output schema formats. Then we are calling the OpenAI LLM by passing the model, system prompt and user query. Here we are getting the LLM response. Using this, we are checking the any field is missed in the LLM's response. If any field missed, we are returning their error message. Otherwise, we are returning the LLM's response. Now we got the intent plan here. Next, we are defining the context structure. It holds all intermediate data collected from different MCP servers. It is passed to the final LLM to generate the response. The context structure fields in exam. It stores detected exam events, calendar events, list of upcoming events, notes, retrieved notes from the notes server, notes summary, short summary of notes, topics, extracted key topics from the notes, study plan request, inputs needed to generate a study plan, quiz, generated quiz questions, servers used, tracks which MCP servers are called. Next, we are calling the start underscore servers. This function launches multiple MCP servers using subprocess. Each server runs independently like microservices. We are starting the MCP servers from our MCP agent code, but we can also start them manually if needed. The reason we are starting inside the agent code is to manage all servers in one place and easily monitor their connections. Wait underscore per server, make sure all the servers started properly. Next, AsyncExitStack. It's an advanced context manager from Python's context lib. It helps manage multiple async resources dynamically. When execution exits this block, all sessions are closed properly. Next, connect sessions. It connects to each MCP server via HTTP streaming, registers each connection inside the stack, and then returns the session dictionary. If LLM's response intent plan says calendar data is needed, the agent calls the calendar MCP server tool, get upcoming events. To fetch the upcoming events, it extracts the events, identifies an exam, and stores it in context for later use. Finally, logs the result, tracks the server used, moves to the next step. We are constructing the context here. If notes are required, the agent queries the notes MCP server using the topic and stores the retrieved notes. If then reads each note, extract key topics, and builds the summarized context for further processing. If a study plan is needed, the agent first ensures it has exam details. If not, it fetches them from the calendar MCP server. It then prepares the study plan with available hours, exam information, and extracted topics. Instead of generating the plan here, it defers this task to the OpenAI LLM for final reasoning. If intent needs quiz, the agent ensures topics are available and determines how many questions to generate. It then calls the practice quiz MCP server to generate the questions based on those topics and stores them in context. Next, LLM final answer. This function generates the final user-facing answer by sending the question, intent plan, and collected context to the OpenAI model. The system prompt guides the LLM to respond strictly based on the intent. Example, only quiz or only calendar or full plan, and to use only the provided MCP data. The LLM composes a concise context-aware response. Finally, the function returns the formatted answer along with the model used for transparency. This final response will displayed on the UI. Now set up and configure. Open the terminal. I already installed and configured. I will show you the how to set up and configure. First, we need to create the virtual environment using this command. If you run this command, it will create the virtual environment. After running this command, you have to activate using this command. Here I have created the requirements.txt file. It contains all the required packages for this application. We can install all this using the pip install command. Now we will run our application. Now I am posting my query. Help me prepare for my AI exam tomorrow. Run this. Notice here, it created the 5 number steps. Each step maps to a different server or an OpenAI call. The agent coordinates all of them. First in zero task is to understand the query intent. Once we got the intent plan, next it based on the intent, it calling the calendar MCP server, notes MCP and the notes MCP server. Then read the notes Fourth step is preparing the study plan. Fifth step is calling the quiz server to get the quiz questions. Preparing the final response here. We'll run one more query and see what exams are coming up. This time, OpenAI returns needs underscore calendar true flag and everything else false. Only the calendar server is called here. Notice that steps 2, 3, 4 and 5 are skipped entirely. The agent adapts based on the intent. Next, we'll run one more query and see. Give me quiz on search algorithms. Notice here, this time agent calls the quiz server and finally preparing the practice questions. Today we built a multi-server AI agent using MCP with Streamable HTTP, where multiple backend services work together. We used OpenAI for intent detection and study planning, so the agent can understand user queries and respond intelligently. The project follows a clean 4-file structure, making the code easy to manage and scale. Finally, we created a Tkinter UI, which runs the complete agent flow end to end. If the video was helpful, please like and subscribe to PraveenTechlab. All the code is available on GitHub. If this video was helpful, please like and subscribe to PraveenTechlab. Drop your questions in the comment and I will reply. Thank you. See you in the next video.